Picking up with problem number 5, we're trying to figure out things dealing with the height of children. So the very first thing that you have to do, and this is not an option, you absolutely must do this, it is to write down your distribution. That is not optional. You must write it down someplace for each question. Kyle, wake up. Do the problems. Once you have that written down, what work you need to show, so since number 8 is talking about, A is talking about what percent is less than 3 feet, change that into inches first. And understand that what we're talking about here is this piece. Your work that can be shown has a couple of different options. Number 1, you have to show the calculation for z-score. That is not an option. You get to choose whether you want to draw the picture with the mean on it, your value on it, and shade, or to write one of those 2 statements. It doesn't matter. Because we're given a value and we're looking for a percent, you do normal CDF and plug it in. We're taking probabilities always out to 4 decimals. Percentages then would be 2 decimals. The second question is talking about the middle 80%. So that means if I were to balance a box, 80% in size, over the mean, half of it goes out in either direction. So I've got 40 in one direction, 40 in the other. So from 50, that takes me to 90 and to 10. So then you would write it like this. I would say find the value that being less than that gives me 10%. Find the value where being less than it gives me 90%. That's okay. There's not much work you need to show for this one. And then you do, since you're given a percent and you're looking for an answer, you're going to do inverse normal. So then your answer, again, putting it in terms of context, is that we have to be between 35.89 inches and 40.51 inches. Okay, for problem C, this is where we all are, right? There's one very important thing that it says. Do you know what's really kind of a glitch here? What makes it something different that you can't go straight with it? Here. It says the biggest 5%. And we can't do the biggest 5. On our calculators and for our work, we have to show the left side. So if I'm looking at this, again, as long as this is written there someplace, I don't need to keep writing it down, but it must be written down someplace for each situation. The biggest 5%, that means I have 0.05, and I'm looking at this stuff. But your calculator needs to focus on what portion? The less than. So if that's 0.5 being above, what is going to be below? 0.95. So what we're looking for here is we're looking for the probability that we're less than some value, and that works out to be 0.95. What command do you use in your calculator? Is this inverse or normal? Inverse. So you do second distribution, inverse norm. This time my area is going to be 0.95. Hey, look, we're still in the same problem. It keeps popping back up. You don't need to remember it. And you should say that we need to be how tall? They need to be taller than, because remember the question was asking to be in the biggest 5%. You have to be taller than 41.16 inches. Again, taking it out to that one more decimal past what we were originally given for accuracy. Yes? Yeah, because if I say shorter than 41, because they want to know at least how tall, you want to be taller than the 41. You want to just make sure that your context is clear. Okay? Anybody understand what the point of D is asking you? What is it asking you? Deviations, you can use that. You can use percentages. Really, the key word here that a lot of people don't understand is it just says only. Whenever you see that word, because they're going to say, somebody made this comment that only this happened. Make a comment on what they said. Well, we want to know, is it okay to say, like, if you say only 33 inches tall, that means you're pretty surprised, right? Something's unusual. So if I'm looking to find out whether something is usual or not, what can I look for? Standard deviations and z-scores. So then that means that for D, they said only 33 inches. So I want to find the standard deviations for 33 inches. Again, that problem was already written down with my given information. If you did not do that yet, you would have to do that. But for stats, as long as there's someplace, you're good to go. That means I'm going to find the z-score that goes with this. So it's observed minus expected over standard deviation. Whoop, that is not correct. 33 minus 36. Over 1.8. 33 minus 36 divided by 1.8. Because I don't know how to read my own writing, I'm special. Thank you for pointing that out. I don't need to know that I'm special. Let's try that again. 33 minus 38.2 divided by 1.8. So I get negative 2.89 standard deviations. Should you be surprised if you get something that's negative 2.89 standard deviations away? Yeah. So then that means I can say 33 inches is unusually short. Dude, I just forgot how to spell unusual. Oh, happy Friday. When you see that word only, just decide, is that unusual or not? You can, if you wanted to, go ahead and find the probability. And if I were to do that, I would have said, if I wanted to find probability, what would I use? Normal CDF, yep. And I would say from the negative to 33 mean standard deviation. That's a really tiny percent. Anytime you get a number that is less than 0.05, that's going to be considered unusual. Okay, this is where our 0.05 is going to start coming in. Either 2 standard deviations or a probability less than 0.05. Okay, so we already went through all of these. Try this one. These are really good questions that work out to be very similar to what your quiz is going to look like. Give it a shot. Now, the first question says, notice that the third quartile and maximum sizes are the same. What's basically a quartile, any of my quartiles doing? What do they say? Right, it just means 25% of the data falls there. And so if I'm talking about the third quartile to the max, what percent of the data is between the third quartile and the max? 25. So that just means 25% of my classes had 40 students in them, at least. That's all that means. Does that make sense? You want to break down what the ideas of, well, what does that distance from the third quartile to the maximum represent? That just means that distance is just a percentage of the population. So at least 25% of the population has class sizes of 40 students. That sucks. Don't go there. Okay? The school district declares that class sizes with enrollments fewer than 20 students are too small. This is not going to be your, well, that's a great prize class. This isn't your personal commentary. We're thinking in terms of statistics. Statistics. Exactly. I don't word good. So we've already said that 25% of my data falls between quartile 3 and the maximum, and it's all the same thing. Would you consider this to be symmetric data or skewed data? Oh, heck yes. This guy is going to be skewed. So should I use mean and standard deviation to describe it, or should I use something else? Something else. So that means I'm probably going to use median and interquartile range. My median here is 33. What's my interquartile range? 11. So when we're talking about means, medians, standard deviations, interquartile range, we're usually talking about outliers. When does something become an outlier with skewed data? More than 1.5 interquartile ranges away. So one interquartile range is going to be 11, and a half will give me a little bit more than 16, kind of 17. If I were to take 33 and from it subtract 17, what would you get? 16, 15, 16, something about there. Would you consider 20 students to be an outlier? No. This goes back to what I was trying to point out with the last question. If you see the idea of only, or if you see, do you think it's too small? We're thinking about in terms of outliers. Yes. That's what we just did. Yeah. Now, so this guy, they're actually using z-scores, which I would not have agreed with because it's skewed data and you wouldn't use z-scores for skewed data. But had that been an appropriate choice, you would use your mean and standard deviation, find your z-score, and then that says it's more than 2 standard deviations away. So they're saying yes on that. I disagree because I don't use mean and standard deviation for skewed data, which this clearly is. Back it up. Okay. C says the school district sets the office supply budget, la 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 la. So it's $12 plus 75 cents per student. So one student gets $12.75. Does that make sense where they're coming up with that equation, like how they're working that? It says, what is the median class budget for the office supplies? So what I'm doing here is I am adding something to my distribution. Does adding something to the distribution change positions? If I gave everybody 5 bonus points, does that change your grade? Yes. Yes, that's why you like getting bonus points. So if I give everybody $12, that's going to shift my distribution over 12. If I times something, if I say, no, I'm going to double your scores instead. She's like, yes, please. Is that going to affect your positions? It's going to stretch it. So all you need to do here is plug the values in. So your median budget just works out what do you get when you plug 33 in. Your interquartile range can actually work a couple of different ways. You can find quartile 3 and quartile 1 using this method. Or you can just say, I know the adder, the addition thing, is not going to affect it. So you could take your interquartile range and times it. You could take the interquartile. Why can you just multiply it? We're going to go into that actually a heck of a lot more when we get to chapter 4, next unit. Okay? Mean and standard deviation does the same. Okay, now I hear a lot of us packing up, so I just want to kind of look at these pretty quickly. Draw and label the model. Just want to make sure everybody understands that when you draw and label the model, things you must have for this. You must have a title, putting it in context. If you have things down here, I want to know what that is. If that's taken care of in your title, okay. This says letters mailed, so that's what those represent. You need to see mean, 3 standard deviations out in either direction, and either the 68, 95, 99.7, or 0.15, 2.35, 13.5, 34, 34, 13.5, 2.35, 0.15. I like the little ones because those are the ones I usually end up using. That's my whole reason behind that. Yes, I realize that's less writing. When you're wanting to compare 2 different unrelated things, find their corresponding z-scores. Whichever direction you consider better, be that positive or negative, take that into mind, and then say who's furthest in that direction from the average. Look at their z-scores. Percentage of employees, when you're looking for a percent, that means you're going to use your normal CDF. And you can see here they give you several different things. They give you either a picture or the statement, or the z-score statement. No matter what, z-score has to be shown. And then for the next one, they're saying you got to have 5 minutes to adjust. That means if we want to make sure that we have that adjustment, then we have to arrive by 7:25 instead of 7:30. And we find that percentage. Okay, do you feel a little bit better? All right, so you guys should understand what's your homework. The Khan Academy stuff. It's going to be really, really good practice. And then on Tuesday, you are going to be taking your quiz over this. Then I will grade it as fast as humanly possible. And we'll review, and your test is on Thursday.